All right, so at this point you should have Python installed on your system, and you should be able to run a simple hello world type program where you just print out a message. So we're going to start to now look at the fundamental parts of the language. A lot of what we're going to talk about today is pretty fundamental to all programming languages. Before I get moving with that, I want to just give you a reminder. Um, This is particularly important if you have not programmed before. Um, it is crucial that you're reading the textbook along with my lectures and listening to videos. The lectures and the instruction that I'm giving is meant to augment and to enhance what you're already reading in the textbook. For each module, I've listed the textbook reading on the web page. If you go to the course web page, before you look at the lecture sides and before you look at the videos that are further down on the page below this, I'll always list what textbook chapters, and generally each module corresponds to only a few pages. You absolutely should be reading that first. The textbook is excellent, and it's not particularly verbose. It's something that's fairly easy for you to read. Um, if you haven't programmed before, you're going to find that this course, although we start out sort of slow, it starts to accelerate pretty fast, and it's likely that you're going to have to read the book maybe a few times before you really grasp the concepts that I'm talking about in the lecture. So make sure that you're doing that work. If you've already programmed before, these next few modules are really outlining very, very basic parts of the language. There'll be some things that are probably pretty useful to you. It might be that if you just read through the chapter headings in the textbook that I'm pointing to in the module, much of the lectures for an experienced programmer is probably really just review, and so you can kind of use your best judgment as to how much time you want to put into these first few modules. Once we get into certainly by functions and classes, you should definitely be really taking a lot of the lectures, looking at those pretty carefully as well. All right, so programs generally, unlike the program that we already wrote that print out at Hello World, programs manipulate information. That's generally why you write a program. Certainly, if you're in the science and engineering field and you're trying to write some programs, you're probably writing it to analyze some data, maybe to display some data, maybe to get to control some sort of a device or something like that. So you're going to have to manipulate information in commands. Programmers call this information data. And in Python, we go a little bit further in that every piece of data that's associated with our program, we typically call it an object. Right? So the word object really just refers to a piece of data, a piece of information. In all programming languages, objects have types. Why this is important is it really gets down to the bits and bytes that we talked about very early on in the first module. The computer has to represent whatever data that you want to store as binary numbers. And it's as we saw, something like a color would be represented as a binary number. Something like a character would be represented as a binary number. And the thing is that the same binary number might mean, the character A if it's interpreted as a character, or it might be the color red if it's interpreted as a color. So we need to make sure, as in the programming language itself, that we define exactly what kind of data we're trying to store, in addition to actually storing the data itself, the binary numbers. So in Python, the fundamental data types would include an integer, a real number, which would include decimal places. So integers don't include decimal places. Real numbers could certainly be, integers 2.0, but they can also be 2.1. Character data, and there's another one that I didn't list here, and we'll talk about shortly, and it's Boolean data, true or false data. So those are sort of the fundamental data types that you'll see in Python. There are two categories actually of objects in Python, scalar and non-scalar. And so the ones that I discussed just before are considered the scalar types. They are indivisible. They represent a single piece of information, and they're built in, they're basic types. They're defined by the language. So there's keywords for all this. So int represents an integer, and examples of an integer would just be 3, -5. These are all, pretty self-explanatory. Real numbers are called floats in Python. And in other languages, you'll see float, you'll see double. In Python, it's just float. Float refers to floating point decimal numbering system, and it's a different encoding. So a binary representation of floats is very different from a binary representation of ints, even though it's the same number of bits. So for a float, we can store 3.0, we can store 3.17, and on and on. Boolean type bool really only has 2 possible values to it. All right, so if you have a piece of data that is of type bool, it's either true or it's false, and it's uppercase TRUE and uppercase FALSE. There's another type, and we won't talk about this for a while actually, but there's actually a distinct type called none in Python. It represents the absence of data, which every once in a while is actually a very useful fact, right? You might have to store the fact that maybe you do not know how many things you have or something like that. So none is sometimes comes in handy. The only value of type none is none. So that's the literal representation. You can print out objects, right? So I can print out the value 3.14159, and that'll come out to the screen. Non-scalar types are compound data structures. One of these is strings, and we're going to see that in Module 2 pretty quickly. But we'll also see lists, things like dictionaries, maps. We'll see all of these different types of data structures later on in this course, and they prove very useful. They're fundamentally different because they represent many things, not just one thing. They're collections, they're sequences of things. Many types of data support operators. So for example, the plus, the minus, which is just dash, and the multiplication, which is an asterisk sign, and division operators work with numerics. So anything that's an int or a float. So for instance, if I type 3 plus 4, I'm going to get a new object with a value of 7. If I type in 2.1 divided by 3.5, I'm going to get a new value, a new object that gets produced, and you might say yield a new number, 0.6. Right? Each one of these, so it creates a brand new object. The combination of objects and operators to yield another object is called an expression. The term expression is very, very important that you understand what this means. Right? It's just something. It's a series of operands and operators, a series of objects and operators that produces new data, that evaluates to a piece of data, that has an answer. There are some Python-specific operators. So plus, minus, multiplication, division, all languages have that. Virtually every language uses the same symbol for that. If you've never programmed before, it comes as no surprise that if you type 5 divided by 2, you'll get 2.5. If you take 5 and divide it in half, you get 2.5. If you have programmed before, though, if you've done any C++ work, Java, you actually hopefully remember that 5 over 2 gives you 2 in most of those languages. So Python is actually a little bit different than a lot of these in that it treats integer division a bit differently. So when 2 integers are divided by each other, most languages, not Python, but most languages will produce another integer. So 5 divided by 2 just produces a new value, 2. In something like C++, if I typed 5 divided by 2.0, then C++ would say, oh, okay, you need floating point values, and it'll give me 2.5. If you're confused by that, or if that seems sort of strange, you'll like Python 3, all right? Because in Python 3, 5 divided by 2 does what most normal people think it should do, right? It returns a float, right? So in Python 3, the division sign, whether or not you use integers or not, always does floating point. It'll give you what you think you want. So in terms of Python-specific operators, every once in a while, integer division actually is really nice. And occasionally we will use it in this course. You'll see me using it. If you want real integer division, there's a different operator, a double slash, that gives you the integer division. And so it's a nice compromise, and it's something that's different than from other languages. Another operator, which most languages have, but most people sort of find a little tricky the first time they see it. It's not one of our standard mathematical operators that we think about in everyday mathematics. It's related to integer division, actually, is the modulus operator. It gives you the remainder of an integer division. So you think back to like long division, when you probably learned that in grade school. Long division had a quotient and then a remainder. The modulus is essentially an operator that gives you the remainder. So 5 mod 2, all right, so normally when we see that percent sign, we should say mod. 5 mod 2 is giving you a remainder of 1, because 2 goes into 5 twice. 2 times 2 is 4, so 5 minus 4, which is the remainder, is 1. 8 mod 3, well, 3 goes into 8 twice, and the remainder is the difference between 8 and 6. All right, so that's 2. So the modulus operator gives you that integer remainder, and again, that's very useful. Things like, for instance, checking to see whether a number is even. You could do a mod 2 and check to make sure that the remainder was 0. Both sides of both left and right side of this modulus operator must be an integer for this to work. Floats don't work for this. Another Python specific operator, which is very nice, is exponents. So most programming languages require you to do some special syntax for special function calling for exponents. In Python, if I want to calculate 2 raised to the 4th power, I can just do a double asterisk, a double multiplication sign. Right? And so that will give me 16. 2 to the 4th is 16. 10 to the 3rd is 1,000. This works for both floats and ints, so I could do 5.0 or 5.5 raised to the 2.5 power, and I would get the right answer. And so that's a nice, useful trick, and again, something that if you've learned another language, that's generally not available. So it's kind of something that's very nice about Python. Expressions are not limited to just mathematical operators, so we're not limited to just plus and minus. We can do comparisons. Right? So the comparison operator allows you to take 2 values and see whether they're one's less than another, see whether one's equal, not equal. The result of a comparison operator, though, is a true or false value. Right? So if I say 3 greater than 4, we know that objectively is false. That's not true. 3 is not greater than 4. The new object that is created is of type Boolean, and the value is false. 4 equals 4, the double equal sign, pay attention to this operator, and by the way, we have greater than or equal to, we have less than or equal to, we have less than, all of those work the same way. The equal sign is a double operator, a double equal sign. We cannot have a space in between it, that doesn't work. If you write 1 equal sign instead of 2, that's an error, and that won't make any sense for Python. So make sure this is a very, unfortunately, programming is extremely detail oriented. The details matter. You can't sort of be kind of right. You have to be very precise. And the operator for comparing, if the 2 things are equal, is a double equal sign. That'll return true because 4 is certainly objectively equal to 4. 4 is not equal to 5, so that yields, true. I don't know where that came from. So 4 is not equal to 5 yields true. The not sign, again, no space in between the not and the equal sign. These are called comparison operators. They allow us to compare any value to another. They can be compound expressions. So I can do something like this. Right? So with a parenthesis over here, I can evaluate the expression 2 plus 2, and I know that that yields 4. And now I can test to see whether that equals 4, and again, that would yield true. Right? So these expressions can be built upon. The last piece to this in terms of forming expressions is logical operators. So logical operators mimic the AND and OR gates that we saw from the first module, module 0. They allow us to do Boolean algebra. we can actually type just literally the word and literally the word true or not. So true and true yields true. True and false, false and false, false and true all yield false. For the ors, true or true, true or false, false or true all yield true. Only one has to be true. If both are false, the result's false. The not operator just inverts. Now, why is that useful? Well, really, instead of saying true and true, we're probably going to have an expression. So we're going to have to say, is 4 less than 5 and 8 greater than 2, right? And so we can combine a relational operator, or a comparison, two comparison operators, and check, are they both true? Or is at least one true? Or is neither true? Okay. Typically, we want to do something with the expressions, right? So when we form an expression in our program, one option is just to print it out. So we could just say, we could type print 4 not equal 6. And if I do that, it'll just print out true to the screen. And so why don't we actually just go and do that? I'll copy and paste this over. I'm just going to go into the source code from the previous module. So if I type in print 4 not equal to 6, and I go and run it, we see true comes out. Right? Typically, while we're probably ultimately interested in printing out a result, more often than not, every time we calculate the value of an expression, we're not necessarily interested in printing it out immediately. Lots of times we're going to use the results of an expression to build into other expressions and to make more complex calculations. To do that, we need to understand the concept of a variable. A variable, and if you take an algebra or something like that, you're familiar with the concept, although it works a little bit differently in programming. A variable is a name that can be associated with an object, or can be associated with a particular value. So we can sort of make that up on the fly. And so I took this screenshot from the book here. We can create variable names. Variable names appear first, at least, on the left-hand side of what's called an assignment operator. So by typing in pi or pi equals 3, actually I didn't type in the full one here, 14159. By typing in pi equals 3.14159, I'm creating an object in memory representing that value, but I'm associating the word pi with it. Right? And anytime that I use pi, anytime that I use that variable later on, it will be associated with that value. I can do the same thing and create a variable called radius. Right? So radius equals 11.2. Right? And here's my 11.2, and radius is associated with it. So now with those pieces of information, I can create another variable called area and set it equal to the expression pi times radius squared. Right? So if you calculate pi times radius squared here, you'll get this value. Right? And the way this works is that when the interpreter sees this statement, it goes to the right-hand side and it actually evaluates this full expression. And once it gets that result, it associates that value with the name area. Now I want to be clear on what's happening on this next statement. Radius is being set to 14.3. Unlike algebra, all right, so algebra, when we set up something like, area equals pi r squared, right, that sort of represents like a rule or constraint. So whatever radius is, area is always pi r squared. Right? Try not to think about that when you're programming. That's not really the way this stuff works. When I go here, and my program will execute from the top down, area has been set to 394.08104. When I change radius to 14.3, radius changes. Right? So here's sort of the before and after. Radius is now equal to 14.3. It's equal to another object. But I want to be clear that area has not been updated. Area is not changed. Area is 394.08104. That's what it was set here. And whatever happens afterwards to any of the arguments or any of the operands here is sort of irrelevant. right? If I wanted to update area again, I'd literally have to type that again. So if I make some room for this, I'd have to go and type and retype it, right? I'd have to re-execute that statement, and at that point, area would be updated to reflect the new radius. Very, very important if you're new to programming to understand that concept. Variables are bound to specific objects, to specific pieces of data, not formulas. Variable names. Naming rules. Variables are case sensitive. So like I said, most everything in programming is case sensitive. If I create a variable of name with the name lowercase a, I cannot call it uppercase a later on. Those are two separate variables. Variable names can never have spaces. If I type my space variable, I've created two variables, probably in an illegal syntax, and my program will crash. There would be two variables, my and then variable. So if you want to have multiple words, you can use an underscore, all right, or you can use different cases to separate the words. Variables must start with letters or an underscore. Right? So it can't start with numbers, can't start with an @ sign. Variable names can have letters, numbers, or an underscore anywhere else. So the second letter in a variable name could be a number, but it can't be like a hashtag or an exclamation mark or an asterisk or something like that. It must be an alphanumerical value or an underscore. The assignment, the equal sign, is called the assignment operator. And you saw me create a variable called x or a variable called radius equals something. Here I'm creating a variable called x and I'm binding it to the value 5. So whenever I talk about x, I'm actually using the value 5. So I'm associating the object 5 with the name x. Typing this, by the way, and again, this is one of those things that are different from like an algebra class. In algebra, we can say x equals 5 or 5 equals x, and we know the equal sign's sort of symmetrical, so it doesn't matter. That is not true in programming. This is not an equivalency. This is an assignment operator. The assignment operator takes what's on the right-hand side and binds it or associates it to the name on the left-hand side. If you write 5 equals x, this is total nonsense. This does not work. Right? 5 is not a name, and by the way, x probably doesn't have a value at that point, so it doesn't make any sense. X equals y is certainly okay. We would take the value in y, or the value that's associated with y, and now we would associate x with that same value. We're assigning x to be associated with the same thing that y is associated with. Again, that doesn't mean x is always equal to y. It's not a formula. If I go and change y, it doesn't change x. This is perfectly fine as long as y has already been assigned to something. So far I haven't, so that wouldn't be good. Right? But as long as y has an actual value assigned to it, this would be fine. Let's look at a couple of things that can go wrong up here. If I look at these two statements separately, this doesn't work, right? Typing in x equals y and then afterwards, a few moments, a few nanoseconds later, saying y equals 5 doesn't work. This will throw an error immediately. And the reason this will throw an error is because when I say x is bound to whatever y is bound to, at this point in time, this is not executed yet. Remember, everything happens in sequence. So at this point in time, you're saying, well, associate x to whatever y is currently associated with. Well, y is not associated with anything, so you get an error. For this next one, I actually want to switch over and diagram this out because this is also a pretty important and a little bit more complicated concept. So I've got the code here. So again, I want to emphasize how important it is to remember that everything happens in a time order. The first thing that happens is a statement, and the interpreter would not have seen any of these statements. So we can think about y being bound to the value 5. Okay. The next statement that's going to happen is x being bound to the value 5 as well. All right. It's being bound to the same value as y. When I print x, I'll print out 5. If we want to think about this, and let me give you an alternative way, I think the book would probably draw it like this. All right, that's fine too. All right? If you want to think about only 1, 5 existing, that's perfectly okay as well. When we get to this line of code though, right, and this is where this is very important, right? When I say y is now associated with 6, I'm not going to update this. 5 does not magically change into 6. We would diagram this as y being now associated with 6. And what I want to emphasize here is that x is still associated with 5. Right? Changing what y is associated with does not change what x is associated with just because we had this. Right? They are not an equivalency. It is an assignment. This ultimate concept is probably the most important thing as a beginning programmer right now. This is probably the most important concept that you're going to get out of this module. Right? It's very critical that you get that concept. Naming conventions. A lot of people will fall into the trap of thinking that the names of their variables doesn't matter. And this couldn't be further from the truth. In programs that only contain 3 or 4 variables, fine. But most programs contain hundreds of variables, and your naming conventions become your best way of writing quality programs. Your name should start with a lowercase. They should be very carefully chosen to represent what they mean. A variable that says my variable really tells you nothing about what it actually contains. It's probably not a very good name. Variables with 2 words, you should definitely separate them. Use an underscore or use a change in case, camel case, and make them descriptive. Longer names are no problem. You don't want to create variable names that are really super long, 30 characters long or something like that. But don't think that variables should just all be 1-letter words. There is absolutely, some people have misconceptions about the way programming works. We sort of have this idea that programmers make things really efficient, which is true, but variable names don't make code efficient. So, being Spartan and creating all of your variable names 1-letter words or something like that doesn't help anything. It actually makes things much worse. So you want to keep your names as relevant and as descriptive as possible. And here's why. All right. So just kind of giving you an idea of why the names are so important. Let's say we had code like this. Right? If you look at this code, I want to only look at the left-hand side. If you look at this code, nothing jumps out at me as to what would be wrong with this. Right? It doesn't seem like there's any problem. Right? I'm calculating a is equal to something that looks like pi. Okay, and I'm just calculating some value derived from that. With proper names, though, right? So if I actually call a pi, and I actually define what I was thinking on. I call this is maybe diameter. And now I write the formula and really use descriptive names. Now all of a sudden, if I look at this doesn't look right. If I go back, an hour later, wondering why my numbers aren't coming out right, and I go and look at this formula, well, area is not pi times diameter squared. Area is pi times radius squared. Looking at it this way, if I named all my variables A, B, C, it doesn't jump out, right? It's possible. You could still figure it out. You could still figure out what the problem is. But things are so much easier to read and to understand what might be wrong if you choose good names. All right, so you're going to consistently see me kind of carefully choosing names in my programs when I'm using formulas. So when I go back, because inevitably we'll have mistakes, we'll use the wrong formula, we'll do something wrong. It's going to be infinitely easier to debug your programs if you use meaningful names. And this all goes back to the idea of readability. Readability, the ability to go and read your program. When your program's 3 lines of code, they're easy to read. When your code is 400 lines, it's much harder. Good names of variables and later on good names of functions make a world of difference, and also comments. All right? Comments are strings of text that start with a hashtag. In Python, we can start something with a hashtag. The rest of the line can be anything that we want. We can type in whatever we want. The interpreter completely ignores it. So we can kind of give a comment and explain what we might be doing at that particular location in code. Remember, you are going to go back and you're going to read your code because you're going to make mistakes, and you're going to have to go back into the code and read and figure out what you did wrong. The only way you're going to be good at that, and the only way, the best way to make that as painless as possible, is by making your code readable.